not necessary. So I asked you to think about what are the potential angles, and we decided that, well, theta could only be between 0 and 90 for our triangles. Actually, when we go further on, not this year, but as you get further, you'll understand that actually we can do sine and cosine and tangent of any angles, right? We apply it to right angle triangles, but we can actually do it for any angles. But I did want to know, for the triangles, for our right angle triangles, are there any values of sine, cosine, and tangent, for instance, that our calculator will give us a problem with, right? So, for instance, I think Jelena came up with the suggestion, and she went, well, it's got to be between 0 and 90, and she told me that, well, sine of, what was it, 0 equals 0. And then she said sine of 90 is equal to 1. So she hypothesized that, well, maybe sine of angles can't be smaller than 0 or greater than 1. So we kind of thought, well, what if we did sine of 45?
Should be.
Can you do it?
It's 0.7071067.
707. Right? So it's not in the middle. But what about sine of 85, for instance?
Sine of 91 is still under 1. Yeah.
We can't do 91, no, can we? Because it's greater than 90.
Sine of 85 is
Adriana?
0.996.
996. What about the sine of 87? Jasmine? 9986.
But you.
Okay. Do we notice we're getting closer and closer to 1? Well, what about sine of 20?
0.3420. 2.
Okay. Hands up, not shouting out. Sine of 5 degrees. Aiden?
0.087.
So are we starting to get the idea that actually sine of an angle has got to be somewhere between 0 and 1? Yeah? So if we do 0 to 90, because those are the only ones we can do, all right, it's going to be an answer somewhere between 0 and 1. Now that has a meaning, because if we try, for instance, if I said to you, sine of theta equals 0.7351, what is theta? Do we all remember how to do that?
Yeah.
Go for it. Everyone went, yeah, I do it now. They're all going, what? What do you mean actually do it? Are you not going to tell me the answer?
47.315.
47 point.
3156.
Okay, degrees. Would you like to remind people how it was done?
Okay, so you do 0.7351.
Yeah.
And you do the inverse.
Remember the inverse sine of 0.7351. However your calculator does that, that will tell you what the angle is. Okay? What is the ratio of sine? So remember, sine theta equals opposite divided by hypotenuse. So I have just told you for this one that opposite over hypotenuse is 0.7351. So for instance, I could say to you, well, I've got a triangle where its ratio is, its opposite side is 7 and its hypotenuse is 23. What's the angle? So we would do theta equals the inverse sine of 7 divided by 23, and we get
0.304. That's the sine of I mean, that's 7 over 20.
Well, what's the angle? I can just put it straight in without rounding it for most time.
17.7.
17.7 degrees. Okay, cool. Everything's working fine. Right, but you're in the middle of a question, right? You're in an exam. Certain members of the class stress massively when they're doing exams. And you write, oh yeah, Mr. Potts said do SOHCAHTOA, and you write that, yeah, I do that, okay. So I've got theta is x, right, good, sorted, that's the one I want to know. I want to know the angle. I've got opposite, adjacent, height. It's exactly what Mr. Potts told me to do. Okay, I'm going to do, I don't need that. The adjacent is 17 and the hypotenuse is 10. Okay, so I'm going to do SOHCAHTOA. No opposite. It's exactly what Mr. Potts is telling me all the way along. So cos of x equals adjacent over hypotenuse 17 over 10. Therefore, x is the inverse cos of 17 divided by 10. And x equals, over to you.
Error. That's what I got. Domain error.
Domain error.
Is it because it's smaller than the adjacent?
Yes.
Excellent, excellent.
Yeah.
Good spot.
So, what I want you to realise is,
I was saying that should be good.
because what you tried to do, if you think about it, what is 17
Illegal.
divided by 10 as a decimal? More than one. It's 1.7, right? We know, actually, we did it with sine. I've just done it with cosine. So what do you think cosine has to be between as well? 0 and 1 again, right? So if you try and work out an angle using a ratio that's more than 1 with sine or cosine, you'll get an error. And normally that's because you got the sides the wrong way round, or you wrote them the wrong way round here, right? But you know the adjacent can't be longer than the hypotenuse. So I just wanted to point out, because it comes up with an error, and it's amazing how many people put their hands up in the test and go, my calculator's broken. Yeah, the calculator up here is broken. One in your hand is fine. It's doing exactly what you're telling it to do. Cameron?
Is the reason why it doesn't do that with tangent is because it doesn't contain hypotenuse, so a opposite and adjacent can be bigger than each other?
Good point. Yeah, so I've only talked about sine and cosine, so what about the tangent? Okay. So we're quite, it makes perfect sense, doesn't it, with sine and cosine that we have to use the hypotenuse, right? So if this is theta, this is opposite. So the hypotenuse must be bigger than the opposite or adjacent. So with sine and cosine, you can't have a ratio greater than 1, because the hypotenuse has to be longer. So we're always, whether it's adjacent divided by hypotenuse or opposite divided by hypotenuse, if the denominator is bigger than the numerator, then you get 0 point something, yeah? As a decimal. You get less than 1. If the denominator is larger than the numerator, you get less than 1. Not domain error, it's fine. However, if we do the opposite divided by the adjacent, is it possible to get it the wrong way round and not get an error on your calculator?
Yes.
Yes.
Oh, yeah.
Because it doesn't matter, does it? So try for me, right? Let's do tan of theta equals 3 divided by 5, and then tan of theta is 5 divided by 3, and tell me what you get. So we're doing the inverse tan of those. When we do those, what do you get?
30. The first one is 30.
The first one, Cameron, your hand up.
30.963.
30.963. And what's this one? Jasmine?
Error.
Say it again. 0.0.
0.03.
Okay. Do you notice anything about those two numbers?
Oh, it's 9.03.
Add them up for me.
Loss. E9.9992.
So basically 90 degrees. Why is it?
Oh,
Well,
because
go on.
they're like both the different sides that have the angle 90 degrees in between them.
Yeah. So if I drew the same triangle here like this, right? I've swapped 3 and 5 around, yeah? So let's just say I make the adjacent, what did I do? 5 on this one. That's what I did. Opposite over adjacent. That 5 and this is 3. But let's say I swap those around.
And it wouldn't be a right angle.
This would be 3 and this would be 5. It would still be right angle.
Oh, no,
I'm just
I thought
swapping
that
those sides, yeah? But which angle am I now referring to? If this is 5 and this is 3, sorry, I've done something wrong, not what I wanted to explain. If I keep 5 and 3 together the way they were, right?
Oh.
It changed like the opposite.
So what have I done? So that's the hyper. What have I done, Cameron?
You focused on the other angle.
I focused on the other angle, haven't I? So this is still 5 is the opposite now, and 3 is the adjacent. Exactly, that's why they add up to 90, because this is always 90. If I add those two together, what do I get? 90.
Yeah.
So if I swap the opposite and adjacent around, I'll just get the other angle, which is why with tan it works, but with sine and cosine it doesn't work. All right? You must get them the right way around. And with tangent, you've got to be especially careful because obviously you might end up working out the other angle, the wrong angle. All right? Okay? Yeah, I'm not going to go any further than that. So we have got to be careful. Be careful that when you do your sine and cosine that you get them the right way around, which is why all the times I've asked you to solve a question, look what it looks like. All right? And that's because we're all about making sure we get the right ratio and the sides in the right place. Okay? Yeah.
What actually happens when you do tan of theta on your calculator? What does it do?
It works out the ratio, tan theta.
Okay.
So the ratio of any possible opposite and adjacent side.
Oh, so it has them all calculated.
Well, no, it has something else, but that's something else to look into in the future. When we do unit circles and things, I can explain to you what a tangent actually is. Right? If you want to look up unit circle in your own time, feel free. We'll be doing it in next year, or you'll be doing it anyway. Okay, so your task now. You might choose to go on to the review exercises. All right, so review at the end of the unit and go through them. So you'll know the level 1, 2, 3, 4, 5, 6, 7, and 8 type questions. If you want to focus on one particular part, go back to that bit in the chapter and focus on just sine or tangent. If you want to do the problem solving questions, do that, but maybe have a look at the review section and see what you can do. No, my iMaths is now homework, so no, you can't do that.